Imagine a computer that can comprehend a foreign language, recognize a face, or even drive a car. How is this possible? The answer lies in the fascinating realm of artificial intelligence, which has been on a meteoric rise over the past few decades. This rise has seen computers and software not only performing tasks, but learning, adapting, and even making decisions. Now, within this broad field of artificial intelligence, we find two key subsets: machine learning and its more advanced counterpart, deep learning. Machine learning essentially gives computers the ability to learn from and make decisions based on data. Deep learning, on the other hand, takes this concept and runs with it, employing complex algorithms and neural networks to mimic the way the human brain works, thus enabling machines to make sense of vast amounts of data in a way that was once thought impossible. So, deep learning is the secret sauce behind these intelligent machines. But how does it work? Deep learning, at its core, is modeled after the human brain. It's a form of machine learning that utilizes a hierarchical level of artificial neural networks to carry out the process of machine learning. These artificial neural networks are inspired by our understanding of the biology of our brains, all the interconnected neurons between different layers of the neural network. This structure of deep learning models allows them to learn directly from data, whether it's text, images, or sound. These models are composed of multiple layers of these artificial neurons or nodes that pass data representations to each other from layer to layer. The deep in deep learning isn't a fancy term, but a straightforward description of the length of the journey the data undergoes. From the raw input at the bottom layer, each successive layer uses the output from the previous one as its input, learning and refining as it goes. Essentially, deep learning models learn to represent data by training on a lot of examples. Now, you might be wondering, how do we train these deep learning models? Well, it's not as complicated as it sounds. We start with data collection. This is the raw material for our model. It's like the fuel for our car. Next, we have pre-processing. This is where we clean up the data, removing any noise, inconsistencies, or irrelevant parts. We're basically refining the fuel so our car runs smoother. Then comes the fun part, model building. This is where we design the architecture of our deep learning model. Think of it as the blueprint for our car's engine, deciding how many cylinders it should have or how the fuel should flow. Once we have our model ready, we start training. We feed the model our pre-processed data and it begins to learn. This is where things get interesting. We use concepts like backpropagation and gradient descent to update the weights in our model. It's like fine-tuning the engine, adjusting the timings and the fuel mixture to get the best performance. Backpropagation calculates the error in our model's predictions, while gradient descent helps us reduce this error by tweaking the weights. It's a bit like a mechanic adjusting the engine based on the car's performance. Finally, we evaluate our model. We test it on new data to see how well it performs. It's like taking our car for a test drive. With each iteration, the model gets better and better, learning to make accurate predictions. It's a fascinating process, isn't it? Deep learning is not just a concept. It's a reality that's transforming our world. It's the invisible hand guiding the progress of technology, leaving its mark in various sectors. Let's delve into some of these applications. In the realm of image recognition, deep learning algorithms sift through millions of pixels in images, discerning patterns that escape the human eye. They're the reason why your photo app can identify faces, or why medical imaging software can detect early signs of diseases like cancer. Then there's natural language processing, which is revolutionizing how we interact with machines. Ever wondered how your virtual assistant understands your commands, or how your email filters spam? That's deep learning in action, understanding and interpreting human language. And let's not forget autonomous vehicles. Deep learning is the navigator, helping these vehicles understand their surroundings, interpret road signs, and make split-second decisions, all with minimal human intervention. As we look to the future The potential for deep learning is limitless. It's set to revolutionize industries from healthcare, where it can predict diseases before symptoms appear, to finance, where it can detect fraudulent transactions in real time. It's also making strides in environmental research, helping scientists understand climate change patterns and predict natural disasters. Deep learning is an exciting field, brimming with potential. It's more than just a buzzword. It's a tool that's shaping the future of technology.